By the time the file is getting uploaded, let me start with the introduction of my company. It's called WiZN Systems. We are a IoT-focused startup based out of Bangalore, a 3-year-old company. I got the slides. Let me just put it. And we provide smart home solutions for the homes. Recently, basically, the early part of this year, we raised our first round of funding, which was led by Foxconn. I'm sorry. Yeah, can you hear me now? Yeah. So early part of this year, we raised our first round of funding, which was led by Foxconn, and they're also manufacturing partners. Let me start with a brief introduction to our technology platform. We have 3 key components. The first one is a low power, long-range wireless protocol, which we have developed from scratch, and which forms the basis of our connectivity between the devices and a Wi-Fi hub. I'm going to spend more time in terms of why we went ahead and built our own protocol, and why we could not use any of the existing protocols in the following slides. The second component of our platform is a cloud solution which has been built from grounds up, and it provides a very efficient and very secure connectivity between the hub, which is at home, and the cloud. And finally, we have a mobile application which is available for both iOS and Android platforms, and it allows users to monitor and control their homes from anywhere. Our product, as you can see, is called Igloo. It's a bunch of hardware devices which we have built. So apart from the hub, we have different kind of sensors like motion sensors, door sensors, temperature sensors, panic alarms, smart plugs, and a lot of devices which go behind the wall units called involved switch modules, which can control lights and fans. Key applications of our product is basically security of home and loved ones, convenience of not doing mundane tasks or repeated tasks, and also to have energy savings and a green living. So the question you might ask is, why a new protocol? We already have Wi-Fi, we have Bluetooth, we have Zigbee, Z-Wave, and a lot of them. When we started developing our product, we also actually went through a complete evaluation of all these technologies and realized that there are some problems in each of them which prohibited for us in terms of using the technology for this particular device. I've listed down some of them. Let me start. Sorry, So the first thing we realized was to achieve the range in a home, we were dependent on the mesh. And the problem with mesh is then when users, we are not certain whether the user would be installing enough number of devices in the home and will be positioning them at the right locations to create a reliable mesh. So that was the first problem with the mesh. The second issue was the latency. So if you look at the user experience in a home, when a user turns or flips a switch, he wants the light to turn on instantly. But with the mesh, that is not guaranteed. Sometimes the message can take up to 2 to 3 seconds to reach the node and turn on the light. So that was another issue in terms of the mesh network. And if you look at all of these protocols, they basically use CSMA technology, which is all these nodes wake up and they transmit data and basically look for the messages. To achieve low latencies, these devices have to transmit very frequently, which basically results in high power loss. And hence, these devices cannot run on batteries. Typically, users don't like changing their batteries every 2 months. So that was another issue we found with a lot of these low power existing networks. One more side effect of this side effect of lower latency or having to have lower latency in these cases was network locking. Since these nodes wake up very frequently and they talk very frequently, it limits the number of nodes that can exist in the network. So as you add more and more nodes in the home network, you would find that you see intermittencies and loss of packets. And finally, most of these technologies were in 2.5 gigahertz spectrum, the ISM band, which is extremely crowded because of a lot of Wi-Fi devices, which can pump a lot more power into the band. And they have to fight with that. And second issue with 2.4 gigahertz spectrum is that the penetration is a problem, especially in Indian homes where we have concrete and stone walls and multiple walls in a house. We were seeing a lot of intermittencies at 2.4 gigahertz for a given power which we could budgeted power. So we went ahead and developed our own protocol, which we call Glue. I'll just go through some of the key features of this protocol and some of the and how we basically took care of a lot of the limitations of the existing protocols. It's a narrow band start network with support for repeaters to extend the range. The line of sight range we could achieve was of 1,000 feet, and it can be further extended with repeaters. If you look at the node, it consumes less than 18 microwatt of power, which if you use a coin cell in a device, it can give up to 1.5 years of battery life. Because we went to sub-gigahertz band of 865 megahertz, and that's the only band available right now in sub-gigahertz in India, and which is an issue because we get a very small band, but because we have a narrow band network, we can still use it judiciously. We could also get 2.5x better RF penetration compared to 2.5 gigahertz. Another key parameter which we could achieve was the transmit duty cycle. This is very, very critical, and I would say when we're talking about LP WAN, duty cycle is one of the very key parameters for most of the networks because there are a lot of nodes which have to talk to each other and communicate, and we have limited bandwidth on the system in terms of the time. So if a lot of these devices communicate very often to sustain the network, then the network will not work, it will become unstable. If you look at some of the most stringent regulations, they prescribe 0.1% duty cycle. So basically, only the transmitters can be on only 0.1% of the time. In our case, we are able to achieve a transmit duty cycle of 0.01%, and which is independent of the latency of the nodes. So when I say latency, it means the time for them to respond. And also, it's independent of the number of nodes in the network. And finally, we could achieve this complete protocol. We could put it into an extremely small microcontroller with a memory footprint of only 12 kilobyte flash and 512 byte RAM. So now we are able to use very low cost, low power microcontrollers to build our devices and make them work. And that basically further helps us in reducing the overall power of the device. So with this, I would like to also summarize my views on the last mile RF connectivity. When I talk about the last mile RF connectivity, it's in the context of the final chain of the signal to the end device. So as I explained in terms of our experience we had with this particular experiment, the existing standards, when they were built for different applications, and they were not planned for the future, for the IoT world which we are seeing now. And hence, they are not fully sufficient or fully capable of meeting all our requirements. The second thing with connected devices is that the applications vary a lot in terms of data rate, in terms of the power we need, the range, latency. So one standard cannot fit the bill for all the applications. So there has to be multiple protocols in coexistence to build this complete IoT world. And our strong belief is that the standardization cannot happen at the last mile level. It has to happen either at the gateway level or at the cloud level. Finally, just to summarize, in terms of the low power WAN, what is the road ahead? As been pointed out by Arvind as well, that we have a huge opportunity for innovation in this case because it's just coming up and we see a lot of limitations. So that brings a lot of opportunity into the system. And we should also look at creating new infrastructure rather than using the existing structures like cellular, and see how we can use innovation to really reduce the cost of connectivity and to really create innovative products. We need a lot more license-free bands. Right now, we have only 2 megahertz band available at 865 megahertz, which is not at all sufficient for this big exercise. So we need to work with government agencies and see if we can get more license-free bands, and also work with them to provide a more level playing field in terms of regulations for the startups to really innovate in this field. I think if we can achieve this now, I'm very sure that we can lead the way. Thank you.